Here's a list of every major contribution Euler made to mathematics, and boy is there a lot to get through. We're better to start than with the notation f of x used to describe a function f that takes an input x and outputs something. I don't know, you'll have to ask what f is. Well, that's something Euler came up with. Speaking of functions, some other notation he introduced includes the trigonometric functions sine, cos and tan, unless he was more of a sec guy than a cos guy. He didn't discover the number e, but he was the first person to call it that. I don't think he was naming it after himself, we just did that later on. He wasn't the first to do this, but he did popularise calling pi, well, pi. Oh, and he's also credited with coming up with I as the name for one of the two numbers that square to get -1. Speaking of e, I and pi, Euler's formula tells us that for any real number phi, e to the I phi equals cos phi plus I sin phi. Or more famously, when you let phi equal pi, you get e to the I pi plus 1 equals 0, aka Euler's identity. Euler was not the most rigorous when it came to analytic proofs, but he did introduce the idea of using the exponential function and logarithms in analytic proofs. He also defined the logarithmic functions as power series and found the value of the logarithm for complex and negative numbers. You just gotta be careful since now it's multi-valued. In fact, Euler used power series a lot and discovered a couple important ones too, like this one for arctan of z. And also his knowledge of power series allowed him to solve the Basel problem in 1735, proving that the sum of the reciprocals of all the square numbers is pi squared over 6. One of Euler's biggest contributions is calculus of variations, including the cornerstone of that whole field, the Euler-Lagrange equation. I could show you what the Euler-Lagrange equation is, but instead I'll show you the kinds of problems it allows you to solve, like the shape with maximum area for fixed perimeter, the shape of a bubble between two rings that minimises surface area, the shortest path between 2 points on a flat plane, on a sphere, and on any curved surface really, even if parameterising such a surface is a nightmare. Before we get into the even purer stuff, Euler also gave us the gamma function, a method for solving quartic equations, and a way to calculate integrals with complex limits, all before complex analysis was established. Now on to number theory. In the beginning, Euler was mainly developing the ideas of Pierre de Fermat, before coming into his own. Euler established analytic number theory, which you may be able to tell is where analysis is used to do number theory. Euler proved the sum of the reciprocals of the prime numbers diverges, like the harmonic series, and a discovery made while proving this led to the Euler product formula for the Riemann zeta function. He used the harmonic series to prove the infinitude of primes, and his work on primes in general would be crucial for the prime number theorem, proven 1896. Euler proved Newton's identities, Fermat's little theorem, and Fermat's theorem on sums of two squares. He invented the Euler-totient function, which he would use to generalise Fermat's little theorem into, that's right, Euler's theorem. He made contributions to the Lagrange four-square theorem and the understanding of perfect numbers, and even conjectured the law of quadratic reciprocity, which is one of the fundamental theorems of number theory, along with the prime number theorem. But Euler did a lot more than working with numbers. In fact, he made a load of discoveries in fields that can for the most part operate independent of numbers. Here's what I mean. Euler proved the problem of the 7 bridges of Königsberg, modern-day Kaliningrad, to be impossible, and this is considered to be the first proof in graph theory. Euler expanded the understanding of planar graphs and convex polyhedra, which graph theorists will know are two very connected things, most notably with the formula vertices minus edges plus faces equals 2, which generalises to v minus e plus f equals chi being the Euler characteristic, for other types of shape and graph. Not only is this a thing in graph theory, but studying and generalising the Euler characteristic formula was the origin of topology, which is nowadays a pretty big deal. Euler was really good at applying analytic methods, including his ones mentioned earlier, to real-world situations. We're talking Fourier series, Venn diagrams, Bernoulli's numbers, Euler numbers, integrals, and continued fractions. He made some major progress in the numerical approximation of integrals, inventing what are now called Euler Approximations. These include the Euler method and Euler-Maclaurin formula. Euler even tried to apply mathematical ideas to music, although his writing in this field was apparently described as too mathematical for musicians and too musical for mathematicians. And finally, how can we forget the Euler-Mascheroni constant, my favourite number in fact. Of course, this is just scraping the surface, which is not what this video set out to do, so we're going to have to go rapid fire with every other mathematical result named after Euler. Let's go. Euler's homogeneous function theorem, Euler's infinite tetration theorem, Euler's rotation theorem, Euler's theorem for differential geometry, Euler's theorem in geometry, Euler's quadrilateral theorem, the Euclid-Euler theorem, Euler's partition theorem, Euler's laws of motion, Euler force, Euler's four-square identity, the pentagonal number theorem, sometimes referred to as Euler's identity, Euler's formula for the critical load of a column, Euler's continued fraction formula, the Euler-Rodriguez formula, the Euler function, the Euler hypergeometric integral, Euler's conjecture for Waring's problem, Euler's sum of powers conjecture, which was actually proved to be false, all of the different Euler/Eulerian numbers, the Euler-Lotka equation, Euler's pump and turbine equation, Euler rotation equations, the Euler-Cauchy equation, the Euler-Bernoulli beam equation, Euler conservation equations, the Euler-Trichomy equation, the Euler-Poisson-Darboux equation, the Euler transform, 2 different medals, a book prize, a programming language, some software, a Parisian street, a Francilian street, a Peruvian park, a musical scale, a telescope, a font, and an asteroid. Suffice to say, this man got around. Now, I think that's everything. Actually, wait, I almost forgot. Euler believed in, and even wrote about, the hollow earth theory. Oh, and I also think he did some stuff with map projections. But anyway, this video took 24 hours from idea to upload. And if this does well, I'll make more of these. You can go to my Instagram, maths.meme, check out my stories to, suggest the next one. And yeah, I hope you enjoyed this.